Hi, in this lesson video, we're going to talk about the IPv6 multicast addresses. So let's begin by talking about the purpose and the format of an IPv6 multicast. Okay, so here's our familiar roadmap, and we can see there's multicast addresses, and there's actually three types: well-known multicast, transient, and solicited node. And we'll be talking mostly about well-known and solicited node. We'll get to transient as well, but that's the emphasis will be on the well-known and solicited node. As always, IPv6 or IPv4 source address is always a unicast. Destination can be unicast, multicast, or anycast. In this case, we're talking about multicast. So multicast, as you probably know, is used when we want to send a packet to multiple destinations simultaneously, the one-to-many scenario. It's equivalent to the 224.0.0.0/4 in IPv4. And I've got two types. It's actually three types of addresses: well-known or assigned, transient, and I had two types there originally because well-known and transient can kind of go together. And we have then the solicited node multicast. But like I mentioned, we'll be talking about all three of these. Not necessarily in this video, though we'll introduce it. We'll talk about these other about each one more specifically in other videos. Okay, the multicast range. So multicast addresses actually begin with FF. And that's because the first 8 bits are all 1 bit. So that's where we get the FF. So anything beginning with FF is a multicast. Okay. There are no broadcast addresses in IPv6. I'll talk about a multicast that is similar to a broadcast. But typically when we want, well, we'll get to it, but in scenarios in IPv4 where we might have to use a broadcaster, sometimes we can use a solicited node multicast. What is he talking about? Don't worry, we'll get there. All right, so as far as the flags go, so there's actually in the 4 bits, we have 4 flags. The first 3, 0 is reserved. There's R for a rendezvous point, which I'm not going to talk about here, and P for the network prefix. These all really have to do with the rendezvous point and the network prefix really have to do more with multicast routing, which we're not going to go into in this course or in these videos at least. The 4th bit is known as the transient flag. And this actually denotes 2 types of multicast addresses. Permanent, when it's a 0, these are predefined multicast addresses, known as also kind of sometimes known as well-known multicast addresses. And that's really what we're going to be talking about in these set of videos. And I have some examples coming up that we'll talk about. When that is a 1, it's a non-permanent, transient, dynamically assigned. This is when it is assigned by the multicast application. So if you've developed an application that runs over multicast and you're using a specific multicast address for your application, then you turn this T or transient flag into a 1-bit. But other than that, the ones that we're going to be seeing and talking about in these videos are really the permanent, well-known multicast. Also, it's a 0 permanent for solicited node multicast. Okay. But an example of a non-permanent might be like FF18, used for some multi-application, and that actually has a different scope. We'll talk about scope here in just a moment. Matter of fact, right now. So scope, as you can, so the next 4 bits really designate scope. So just to clarify here, we have, let me kind of bring up this will be FF, and then this will typically be a 0, okay, because the transient flag is going to be a 0 bit. So that'll be 0. And then we talk about scope. So what is in this field here is what we're talking about. Okay, so scope, here's a partial list. 0 is just reserved. 1 is for the interface, so we don't usually use that too much. Link local. So this, don't confuse this with a link local address, but scope means the multicast group. Any packets sent to a group of devices have to be within that network or subnet. Within that link means the router will not forward these multicast packets. Yeah, but we can have site local. That's another common one, meaning these are for multicast packets that you want to send within your organization or your site. So that can also be your organ. So when I say the difference between site and organization, so site is within your organization without having to forward them out to the internet. But what if you have your site, your organization has several sites that in different locations. Typically, you'd use a VPN to connect these, and your link local scope would be organizational local scope. We won't be getting into those. We'll be really talking about the first 1, 2, and 5. And E is global scope. Okay, so as I've stated here in RFC 4007, there is no automatic mechanism for routers to filter multicast packets. So these boundaries, these scopes, have to be filtered on the router. You have to configure this. There is one exception, and that's that scope with link local scope, FF02. So just so we're clear here, we have F0, because we're talking about either well-known, assigned, or solicited node. And then we're going to put a 2 here. Okay, and that's where I'm showing, that's where we're seeing these addresses here. That's where the 2 comes from. Okay, so these are addresses with link local scope, meaning the router will not forward these. We can see that we have a couple here that all IPv6 routers. That's for any router. This is a packet for any router on my network, not on other networks, my network. So the router would not forward these. Link local scope. That opposed to FF05, which would be also all IPv6 routers, but this is all IPv6 routers that have a scope of 5, site local, so within my organization. So what denotes the difference between, what makes it all IPv6 routers? We're going to see that in a moment for both, but it's this part of it right here. Notice we have the : 2, all zeros and a 2. That's the all IPv6 routers. What designates scope, whether we're talking just on my network or within my site, is the scope field, whether it's a 2 or a 5 in this case. Okay, so multicast address with link local scope has these characteristics. It's multicast, not a unicast. Can only be a destination address, right? Because it has to be a unicast to be a source address. Can be sent to a group of devices on the same link and is not routable off the link. That's that 2 scope. Link multicast with link local scope. It is typically a solicited node multicast. We'll be seeing that when we get into solicited node, or a well-known or assigned multicast. Okay, and we'll use for like neighbor discovery and routing protocol messages. We'll see some examples of this. So don't confuse that, this FF02, maybe I should have another colon there, huh? There we go. With a link local unicast, okay? This is for reaching a specific device, depending on the interface ID, on your network, on your link. This is unicast, one-to-one. This is one-to-many, okay? This is link local scope multicast, meaning it won't be forwarded off your link. And link local unicast addresses are never sent off the link. Okay, so here I'm talking about the link local unicast. I won't go into detail here, but it's unicast. It can be a source or destination address. Remember, multicast addresses can only be destination addresses. A link local unicasts are never routable off the link. Okay, multicast with link local scope and link local unicast. Actually, let's see an example of using both. Okay, so a router solicitation message coming from the WinPC here. This is when the host, WinPC in this case, boots up or connects to the network and wants to send out a message saying, hey, who out there is an IPv6 router on my link, on my network? I need to know how to receive my addressing information dynamically. That's what a router solicitation message does. And as we can see here, it is sourced from a link local address. That's a unicast address. Okay, so that comes from this device's link local address, unicast. But the destination address is a multicast with link local scope. Okay, this multicast address, as we'll see more in a moment, says this packet, my request for a router advertisement message, my search for an IPv6 router. I'm sending this to an all IPv6 routers group. So we'll see that routers belong to this group. But the two means this is sent with link local scope, meaning this router solicitation message, router, don't forward this out other interfaces. Okay, this is just for routers on my network, my link. Okay, now what's interesting is the router advertisement message actually comes back from the router's link local address, unicast address. Okay, and is sent, actually not sent as a unicast. We may think because this device is requesting it, that the router sends it specifically to this device. But we will talk more about this later, but the router advertisement messages are always sent as multicast. It says, well, I know you're requesting this, but I might as well let everybody on the network know. That's what the router's doing with this router advertisement message. I'm going to send this to a special group, all IPv6 devices. Sounds a lot like a broadcast, doesn't it? It's for everybody that's running IPv6. Okay, and that's what the FF0, the 1 is actually, we'll see here in a moment, all IPv6 devices. The 2 is link local scope. Now, remember, we'll talk more about this later. When WinPC receives this router advertisement message, it will actually take this source IPv6 address, which is a link local address, unicast, and that will be its default gateway. That's where we'll send packets when it's not on, for packets not on this network. All right, so that's the difference between multicast with link local scope and a link local unicast. All right, so well-known, let's talk about well-known IPv6 multicast addresses. Okay, we're going to talk about these right here. Okay, they are assigned by IANA, and you can get a full list of them right at that address, or just Google, search for IPv6 multicast address space registry. All right, so we've already said that it's FF, okay? So we already know this is FF. Okay. We know the T flag is 0. That's where we get a 0 here. Okay. We said that these are equivalent to 224 IPv4 multicast addresses. We'll see that these are typically used for neighbor discovery and routing protocols. And let's go ahead and take a look at some of these. Okay, so we'll take, this is just my chart from the book. We don't have to worry about interface link local addresses, but here's a list of some different ones. Okay, we're going to take a look at it a little different way. All right, so our prefix is FF. Our flag is 0, okay, because they're assigned multicast. Okay, and the scope is 2, link local scope. The group ID, or these next these last 64 bits is really what we're concerned about. But let me back up here. FF02::1 is all devices, all IPv6 devices. 2 at the end is all IPv6 routers. Okay, so really what we're looking at is for all devices and all routers is this last number. Of course, they're both going to begin with FF. They are going to have a 0 because they're well known. The scope could actually differ, okay? But the most common is link local scope. We'll see an example of that in a moment. Here's FF02::5. This is for all OSPF v3 routers. So this is OSPF routers running the OSPF routing protocol for IPv6. Okay, there's some more examples. These are all routing protocols here. EIGRP, it's actually a 10. Well, let me talk about that a little bit here. So these are all multicast with link local scope. What's interesting about this last number for routing protocols, 5, 6, 9, this is equivalent to a 10 in decimal, is these are the same addresses used in IPv4. But in IPv4, let me make a little room here. For example, all OSPF routers begins with 224.0.0.5. So this would be the same in IPv6 as it would be for OSPF and IPv4, the last number. So they did that. They kept this last digit consistent across IPv4 routing protocols and IPv6 routing protocols. Okay, so here's actually an example with site local scope. So here we have that same all IPv6 routers, but notice instead of FF02, we have FF05::2. The 2 is the all IPv6 routers. Okay. To implement this, by the way, you need to enable IPv6 multicast routing on the router. Okay. Is something that I won't be going into any detail here, except we will talk about this last one, relay agents, in chapter 8. All right, so here's an example of an assigned multicast address. So here, first of all, the router is enabled with the IPv6 unicast routing command. That makes it an IPv6 router, okay? I'll talk more about that in a little bit. So this packet is going to come from FE80::1, the router's link local address on this interface, and it's sending it to FF02::1. This is the all IPv6 devices multicast. Okay. So who's going to see this? Okay. Got some flashing here. So it's actually going to be sent out to all devices, and all devices will process it. Is this the same as a broadcast? The answer is really no, because we're going to see here, when encapsulated in an Ethernet frame, it's Ethernet destination MAC address is not a broadcast, but a multicast. And we're going to see that this allows IPv6 to handle things much more efficiently than we do in IPv4. We'll get to that in a moment, but it's actually a big reason why in many cases we use a solicited node multicast address instead of a broadcast that we would use in IPv4. We'll get there, so just hang in there with me. Okay, so let's verify the IPv6 multicast addresses on a router. First of all, notice I've used this IPv6 unicast routing command. I can configure a router with a global unicast address, which gives it a link local address by default, and here it created one by itself automatically. Okay, you can see that the FFFE. So use EUI 64. I can create a global unicast address and have a link local address without being an IPv6 router, but I can't do any routing. To be an IPv6 router, I have to use this command here. That allows me to forward IPv6 packets, which is my job as a router, to forward packets from one network to another. It also does another thing. This command, IPv6 unicast routing command, also tells this router to send out ICMP v6 router advertisement messages on its LAN interfaces. That's the type of message that informs clients on how to receive their IPv6 addressing information automatically. Okay, but let's take a look at some of the unicast addresses, or I'm sorry, multicast addresses that this router belongs to. First of all, because this interface has an IPv6 address on it, at least a link local, it belongs to the multicast group, all IPv6 devices. Because we configured IPv6 unicast routing, it belongs to the multicast group, all IPv6 routers. FF02:2 FB doesn't mean that it belongs to Facebook. What it means is that it has to do with multicast DNS. You can see my book for more information on that. These next two, wow, where in the world did those come from? Okay, we're going to take a look at those a little later. They actually have to do with, these are the multicast addresses that they're known as solicited node multicast. And I want you to notice something though. Notice that they both begin with FF02:1:FF. Okay, so I'm going to try and put a line here best I can through both of these. Okay, so that's what makes it a solicited node multicast. Okay, what about this last part? Do you notice any assembly to any association to other addresses? Notice that this 00:1 has to do with this global unicast address. Notice that 93:DA00 has to do with this 93:DA0. Okay, so we're going to talk more about this, but there's something to do with these last 24 bits being the same between its two unicast addresses, link local and global, and having solicited node multicast addresses. We'll talk more about that when we talk about solicited node. Okay. My Windows PC, you want to see, you want to see on your Windows machine what multicast groups it belongs to? Use the netsh interface IPv6 show joins command. Okay, now I put in these comments here to make it easier to see. But again, look at this. It does belong to the all IPv6 devices, just like the router. Okay, this is actually with local scope. So this is for its interface, but also it says I belong. So this isn't used a whole lot, but here's the one with link local scope. Okay. I'm not going to get into multicast name resolution, but I do want you to notice the two for solicited node again. Okay. We'll talk more about these when we get into solicited node multicast. But again, this first actually is 104 bits, say it's solicited node. And this one here is associated with its global unicast address. And this is associated with its link local address. Well, what is that association for? We'll see. We'll see. Okay. How do I look at my multicast addresses on a Linux PC? I can do netstat space -G. Shows it in slightly different order and shows me some things in slightly different ways. But let's start at the bottom. Here's my all IPv6 devices local scope. Here's my all IPv6 devices link local scope. Okay, it actually just says this. It actually resolves it. It says IP6 all nodes, but this is the actual address. There's that multicast name resolution. But here's those two solicited node multicasts that keep on cropping up. Again, look at this. This first, on the left side, means solicited node multicast. And this address actually has to do with its global unicast address. And this is associated with its link local address. We'll be seeing that later and why that's not just important, but very useful. All right. So that's a little introduction to the purpose and format of the IPv6 multicast address.